But what if we wanted to know what was happening up in the atmosphere a bit further back? Actually, a lot further back, before we were even taking any measurements? Well, it is possible.
It sure is, Dr. Rob, and it's all thanks to these. Hi, I'm Dr. Cathy Trudinger, and today I'm going to show you how we're using these polar ice cores to provide a picture of what the atmosphere was like thousands of years ago. Ice cores are basically long cylinders of ice that have been drilled out of ice sheets, like the ones that cover almost all of Antarctica. Since the ice there never thaws, all the snow that falls builds up over time. Each new layer of snow contains particles and chemicals that were present in the environment when it fell. As the snow is compacted, air between the snowflakes gets trapped into tiny bubbles in the ice. And that's what we're interested in. By carefully analysing the air and ice core samples, we can learn a lot about what the atmosphere was like in the past. But how do we get these ice cores in the first place? Well, we send some of our scientists to Antarctica to extract them. To do this, they drill a deep vertical hole into an ice sheet using an ice core drill. They can drill a long way down, sometimes to more than 1 kilometre below the surface. Once they've hauled the drill back up to the surface, the ice cores are removed and put in a freezer so they can be transported back to our lab. This is the freezer where we keep some of our ice core samples. We also have hundreds of metres of ice cores stored off-site at a huge warehouse. Ice core samples are measured for the isotopes of oxygen and hydrogen in water, for dissolved chemical compounds and for particles like dust. All this information tells us what the temperature and winds were like at the time the snow fell. Here in our ice lab, we extract the air from samples of ice. We use a device that works like a cheese grater to release the air without melting the ice, because melting can affect some of the gases trapped in the bubbles. We then take the air sample across to our gas lab for analysis. Here we analyse the air using special high-precision instruments like this gas chromatograph. They are able to measure gases like CO2 and other greenhouse gases, as well as ozone-depleting gases. If you have a look at the screen here, it shows measurements from the ice core of 3 greenhouse gases, methane, carbon dioxide and nitrous oxide, over the last 2,000 years. You can see the levels were quite steady up until about 200 years ago when they started to increase rapidly with industrialisation. At the moment, our records on Antarctic ice go back about 3,000 years, but there are other records that go back about 800,000 years. Our focus, though, has been on the period of industrialisation to try and find out what the atmosphere was like and how it has changed since we started to emit gases into the atmosphere. And so what have we found out from all this ice core research that we've been doing over the past few decades? Well, we have discovered that we have a whole new atmosphere, one that is elevated in compounds like CO2 and methane, which keep heat in the atmosphere. In fact, we've seen large increases in all of these climate-warming gases. As well as knowing about these increases, we can also attribute the causes of the changes. We can say that a lot of the CO2 increase over the past 200 years has come from a combination of fossil fuels and from land clearing. The amount of information we can find in these ice cores is really quite incredible. It's really quite amazing that something like a humble piece of ice can teach us so much about our planet's past.